each and every light energy, the light which is incident over a substance, acts as a packets of energy, and that packets of energy is called as quanta. Angle ABC is congruent to angle ABC. This proves the congruency of the triangles, what you actually study in mathematics. The ratio of sine of angle of incident to sine of angle of refraction is said to be a constant, is what we have studied from the Snell's law, from the law of refractions. Hello everyone, I am Vrinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to session 1 of chapter 10, that is wave optics. In today's chapter, we are going to study about the wave nature of the light. So, you know that light acts as a wave as well as particles, which you study in dual nature of matter. Okay, so here in this case, many of the experimental conditions proved that is, light is emitted in the form of minute particles, okay, and that minute particles was named as corpuscles, okay, which is carried by with a certain kinetic energies is what it was considered because of the one type of the experiment. Later onwards, a scientist called as Christian Huygens, he proposed a wave theory of light. So here it was considered as light is a form of minute particles called as corpuscles, but Huygens wave theory told that it gave about the wave nature of the light. As a result, it was given that the light propagates as a mechanical wave. The propagation is as mechanical wave. Later onwards, Maxwell, he concluded that the change in electric and as well as magnetic field, both electric field as well as magnetic field changes, it resulted in the propagation of light. And how is the propagation of light? It is in towards the one single direction, and electric waves as well as magnetic waves both are perpendicular to each other. This is how actually it travels. Next, later it was concluded that the light is a form of photons which behaves like a particles. So, each and every light energy, the light which is incident over a substance, acts as a packets of energy, and that packets of energy is called as quanta. Okay, so this was given by quantum theory. Okay, this was given actually by the quantum theory proposed by Maxwell, which was taken by Albert Einstein for the later on concepts. Okay, so this, because of this, we got to know that light behaves as a particle as well as wave. There was a particle nature of light, wave nature of light. Both was proved under certain experimental conditions. Okay, so now having all these introductory part, we have that we are studying the wave nature of optics, because of which the topic or the heading says that it is wave optics. Wave optics means we are studying the wave nature, complete wave nature of the optics, and the optics what we consider here is a incident light concept. Okay, so for now, for this wave optics, we have something called as wave front. Wave front, which means to say, suppose if you drop when you were very small or young children, when you were kids, you just drop a pebbles to the water when you go to your native or nearby your home places and all, when you come from school or all these things you do, that you would throw one stone into the water or a reservoir or a pond. So in order to listen to the sound, or else you would have a competition with your neighbors, with your friends and all, just who will throw the stone to the farthest point is what you were considering, right? So now same concept is being decided over here, which in you will have to use your mind, that is a logical mind, wherein some science is there behind that action, that game. Right? So that is, you're holding a stone and you're just dropping into a water. Suppose you have dropped inside, so you can see these reactions. So you know that there are waves. So here is the originating wave, first wave, second wave, you can see third, fourth, here fifth, sixth wave, seventh wave, half of the waves. It's like this. Right? So now when you take this can be a center point, and for this we have the wave nature. And the wave, the particles which is present, the one which is invisible is present over here. The particle which is present over here are having the same phase. It is having the same phase during its movement. Understood? So such kind of a locus, these points are called as locus, possessing the same phase is known as wave front. The locus having the same phase is known as wave front. Okay, the locus of a point which has same phase of oscillations is known as wave front, is the concept what you study here. Understood? So, having this concept, let us move even more forward, that is Highgens Principle. This Highgens Principles gave that means suggested that there are two principles given by Huygens. Christian Huygens has given two principles for which he talks about the wave theory of wave theory. Okay, Huygens wave theory, it worked on the principle which was given by him. There are two principles here. Okay, the first principle says each point on the wave front. That means if suppose this is a center point and here the waves are formed, each point which is present over here, each point on the wave front is the source of the secondary wave front. It acts as a disturbance or a source to secondary wave which forms. Okay, the primary wave acts as a source for the secondary disturbance. Clear? That is what it is given over here. Each point on the wave front is a source of secondary disturbance, and the secondary wavelets which originate from these points spread out in all directions. It starts spreading out in all directions with the speed of the wave. Understood? So this is the first principle given by Huygens. Okay, having the first principle, they are going to explain about the second principle. So what does the second principle tell? Here it goes. The new wave front at any later time is obtained by taking. So there is a new wave front. In order to take new wave front, what is that we have to do? Taking tangential surface in a forward direction. You can see there is a forward direction which takes the tangential surface over here. Forward direction to all the spheres of the secondary wavelet. They take, this is, if suppose this is a secondary wavelet and this is a sphere of the secondary wavelet, half of the sphere is given. If you draw a tangent to it, you get another wave front. Again, if there is a sphere, what is created here, drawing a tangent to it, you get another wavelet here. Understood? Wave front. Okay. So this, the preceding wave acts as a primary source for the secondary wave to form. Now, whichever secondary wave is already formed, that acts as a source for the next wave, upcoming wave. Understood? So, after the formation of a new wave front, it spreads in all sort of direction is the principle given by Huygens in two of the points. Okay. So, now we need to check what are rays. The energy it travels perpendicular to the formed wave, that is the wave front. This is known as a ray. A ray is always a perpendicular direction or a perpendicular line which is drawn to the wave front which is formed. Okay. Having these concepts, next moving on to reflection of plane wave using Huygens principle, which is important. Okay. For 3 marks usually they ask reflection of plane wave using Huygens principle, for which we have got a diagram to be written. That is, we know that this is the surface. For a surface, in order to get reflected, what we had studied in ray optics and optical instrument was reflection occurs only in one side. whereas the other side is completely silverized or it is polished, right? So here one side it is said to be polished because we are checking only the reflection, for which we have, there is a wavefront A and B, call this as A, call this as B, wavefront, which is incident on the surface, name it as X and Y. Suppose there is a incident radiation, it is given in this point, okay? So now, even A is one sort of incident radiation, B is one point of incident radiation. So just extend the line of B. So here it is incident. The arrow marks tells that it is hitting the surface XY. Okay. So now, when it is incident, when you just draw normal, the reflected ray goes out to be in this manner. Okay. So now, similar way, when you just consider a point which is normal to it, the reflected ray, it jumps out to be in this manner. So reflected ray is given by the arrow mark which is given like this. Okay. So these two are incident, their reflections are seen like this. So if this is A, this is B, let me call this as C. From C, that is from A, you just mark a point over there, over the A, and draw a tangent from C to D now. Drawing a tangent from C to D, you have this kind. Okay, so it is said that AD and BC are said to be kind of equal. So you can say that the B makes 90 degree and D with respect to ADC makes 90 degree. So here we have angle of incidence because incident is from this manner. Here the reflection takes place, so you can write angle of refraction there. Understood? So these are the concepts basic concept what you actually have for reflection of plane wave. Using Highgens principle is what we have done. So we know that velocity is equal to distance by time taken. The distance that is to travel and hit here and to travel and go there, that is reflection and all, we just go with D. D is the distance. So D is equal to V into T we are supposed to take. What is the distance here? It is BC. BC is equal to V into T. And similarly, we have AD is equal to the same, it is V into T. Both are same. Now starting on with considering triangle ABC and triangle ADC, two triangles, we know that ABC is 90 degree. Angle ABC is 90 degree. And angle ADC is also 90 degree. And BC is equal to V into T and AD is also is equal to V into T. Okay, we are checking for this triangle and this triangle. And AC is said to be common for both the triangles. AC is common for angle ABC and angle ADC. Okay, because of which we can say angle BAC. Angle BAC is equal to I, right? And angle DCA is equal to R, right? So all are equal. This triangle is equal to this triangle and we have a common base, because of which we can say that Angle ABC is congruent to angle ADC. This proves the congruency of the triangles, what you actually study in mathematics, right? So now, angle BAC is equal to angle DCA. Angle BAC is angle I is equal to angle R, which proves the laws of reflection. Angle of incidence is equal to angle of reflection is one law which proves that. Understood? So, reflection of plane wave using Highgens principle. Why reflection? Because this derivation obeys the laws of reflection as we have got there. Okay? Very easy, very important 3-marker question. Next, let us just move to refraction of a plane wave using Highgens principle. Same like reflection, we have got something with us, that is refraction, for which we will have to have a XY surface. It is called as intermediate surface. Now, since the refraction happens, there is no silverizing or polishing of the mirror. Okay, so there is a line, that is a ray which enters, call it as A ray, B point of the one single ray. So a light ray which enters like this, when we just draw a normal, it moves towards the normal. This is a rarer, this is a denser medium. Okay, so now the light ray which comes and falls incident over this Y region, when we just draw a normal, it moves towards the normal. It bends towards the normal when it travels from denser to rarer to denser medium. So the velocity of the light which travels from here can be given as V1 times the t. The distance from here to here is called as V1 times the t. Okay, distance to travel for the light is velocity into time taken. So from B to C it is V1t. Okay, so just draw a tangent from C to D such that it meets at the point over here at D on A. Okay, so the distance of the refraction from A to D is said to be V2 into T. So these are the few concepts what we know. So now we know that BC is equal to V1T and AD is equal to V2T. In case of refraction, we have something called as Snell's law. Sine of angle of incident ratio, sine of angle of refraction is equal to a constant. The ratio of sine of angle of incident to sine of angle of refraction is said to be a constant, is what we have studied from the Snell's law, from the law of refractions. Okay, so now we have BC is equal to V1 into T, AD is V2 into T. So suppose if you consider sine, this angle is I and this angle is R. So sine I means we need to consider this triangle. This will be the triangle what we consider. So angle ABC. So triangle ABC is considered as this, let it be the base A, B they have considered as the base. This is the hypotenuse. AC is common for both the triangles which is being considered as hypotenuse. So AC is a hypotenuse. That means BC will be opposite hypotenuse and it is adjacent. So sine I, sine is nothing but opposite by hypotenuse. Opposite is BC, hypotenuse is AC. So you can call it as sine I is equal to BC is nothing but V1 times the T divided by AC. So this equation, consider it as equation 1. Okay. Next we are getting on to the second set of equation for sine of angle of refraction. So sine R is equal to, so here is a right angle triangle. AC acts as a hypotenuse. Okay. and AD acts as a opposite, DC or CD acts as a base. So now we have sine R, opposite by hypotenuse. Opposite is AD, hypotenuse is AC. So opposite is V2 times the T is what we are having here, divided by AC. Call this as sine R, and this is considered as equation 2. Okay, so we have on dividing 1 and 2, you have sine I divided by sine R is equal to V1t divided by AC into V2t divided by AC. AC cancels with AC, T cancels with T, so sine I by sine R is equal to V1 by V2. This is the equation which proves, or it is N2 by N1 which is equal to N. It is a constant which proves that the refraction of the plane waves using what? Highgens principle. We have used Highgens principle and we have proved the refraction of the light. So this is all about the reflection and refraction. This is also very important for 3 marks. Either of the two questions they might ask, and it is important. Having all this, even more stepping down into a deep topics of these wave optics, we are jumping on to what is meant by Doppler effect and the light sources. Doppler effect means it is observer, you have source. Okay, so it is the distance between, the one which gives the distance between the source and the sound while traveling. It can be sound waves, which you have studied in your first PUC, and the second PUC you are studying about the light. Okay, so Doppler effect means the complete thing of like source as well as observer's distance, what you study over there, the distance between source and the observer. And actually when the source is very near to the observer, then the intensity is more. When the source is away from the observer, the intensity is less. Understood? So having this Doppler effect, we have got two types. One is red shift, another one is blue shift. Red shift and blue shift. So what is that we study here? Which has got longer wavelength? Red color. Red color has got longer wavelength, because of which we use it in traffic lights and all, because when the vehicles are coming from far, they need to observe the light, that is, it is stop, which means to say it is red in color. Correct? Why we use red color in traffic lights? Because of its longer wavelength, which means to say we have a red shift over here. The distance between the observer and the source is said to be long. Okay? And when it comes to blue shift, it is a shift wherein blue color has got shorter wavelength, right? And the shorter wavelength can it be seen for a greater distance? No, it can be seen only at the shorter distance. So for which we have written that the observer as well as the source are at, that is, source is getting nearer to the observer is what we study under blue shift. So the wavelength in case of this red shift is longer. Wavelength is longer, whereas frequency decreases. Wavelength and frequency are like inversely proportional, right? Where in this case, the wavelength decreases, whereas frequency increases. This is what we just check in case of the Doppler effect. Got it? In case of light waves. So, here are some light sources what we actually use for. There are two kinds of light sources called as coherent source and incoherent source. Coherent source and incoherent source. So what we study here in the sense, the coherent source are the ones which is having zero or constant phase difference. It is having zero or constant phase difference, whereas incoherent source are the sources which is having different or varied phase difference is what we study over here. Coherent source are the source which is having a phase difference either zero or constant. Incoherent source are the source which is having different phase differences. So we make use of the coherent source now. Having the coherent source, we just give, that is a light source, we just gave an introductory part to a interference. What is interference of light? Interference, the word itself tells something is interfering, right? So interfering is, there is a clashes, right? Wherever someone interferes in your matter, there exist a clashes. The same thing is happening with in case of light also. That means to say, there is only one single source, what we study under this chapter, which is being sent through two different, this is a source, which is being sent through two slits, because of which they start interfering. There is an interference pattern, modification in the pattern. Modification in the pattern due to the disturbance which is caused. That is called as interference. Understood? So that's all about today's class. So in today's class, we have studied about the introductory part of wave optics, what is meant by wavefront, Highgens Principle. So based on Highgens Principle, we had studied reflection of light, refraction of light, and finally we studied about the interference pattern of the light and coherent source, incoherent source, as well as the Doppler effect. Under Doppler effect, we had studied about the red shift as well as blue shift. Let us all meet in our next class with the upcoming session of the same chapter. Until then, have a good day. Thank you.